Welcome to today's daily AR14 CS paper drop. We've got 338 new submissions, with computer vision leading the charge at 90 papers. Machine learning and artificial intelligence also show strong numbers. It's a robust day for core AI research, highlighting rapid advancements in visual understanding and intelligent systems. Let's dive in. Starting with an exciting contribution, Circumventing the CAP Theorem with Open Atomic Ethernet, by Paul Borel from DLUS challenges a foundational concept in distributed systems. The CAP theorem is often treated as an immutable law. Under network partition, a replicated service must sacrifice either consistency or availability. While the theorem is correct within its standard asynchronous network model, this paper argues that Open Atomic Ethernet, or OAE, fundamentally shifts the engineering regime where these CAP trade-offs become visible to applications. OAE achieves this by replacing traditional fire and forget link semantics with a property called bisynchrony, involving bounded time bilateral reconciliation of endpoint state. Furthermore, it avoids cross-funnel points through an octavalent mesh, where each node can act as the root of a locally repaired spanning tree. This drastically reduces the frequency and duration of application-visible, soft partitions, by detecting and healing fabric faults within hundreds of nanoseconds, offering a new perspective on distributed system design. Next up, we have Tool Building as a Path to Superintelligence, by David Koplow. This paper delves into the fascinating prospect of large language models achieving superintelligence, particularly through the diligent learner framework, which posits that test-time search can lead to advanced capabilities if the stepwise success probability, denoted as gamma, remains sufficient. The authors design a novel benchmark to rigorously measure this gamma value, focusing on logical out-of-distribution inference. This benchmark involves GF2 circuit reconstruction tasks, designed to become progressively more difficult and require careful integration of all provided information to solve reliably. Their findings show that while smaller LLMs struggle, frontier models exhibit partial robustness. Crucially, the research highlights that successful reasoning at scale is contingent upon precise tool calls, underscoring tool design as a critical capability for LLMs to achieve general superintelligence. Our third paper, Untied Ulysses, Memory-Efficient Context Parallelism via Headwise Chunking, by Ravi Gadia from Together AI, tackles the critical challenge of processing extremely long sequences with transformer models. As AI models demand ever longer context lengths for applications like code generation and document understanding, the memory required for activations, especially in self-attention, becomes a significant bottleneck. This paper introduces UPipe, a novel context parallelism technique that performs fine-grained chunking at the attention head level. This approach drastically reduces the activation memory usage of self-attention, breaking what the authors call the activation memory barrier. UPipe achieves up to an 87.5% reduction in intermediate tensor memory for 32B transformers, enabling support for context lengths of up to 5 million tokens on a single 8xH100 node, all while matching the training speed of prior methods. This is a huge step forward for long context model training. Next, we explore Learning from Trials and Errors, Reflective Test Time Planning for Embodied LLMs, by Yining Hong from Stanford University. Embodied large language models are powerful for high-level task reasoning, but they often struggle to learn from their mistakes, leading to repeated errors. This paper draws inspiration from human reflective practitioners to introduce reflective test time planning. This framework integrates two crucial modes of reflection in action, where the agent internally simulates and scores candidate actions before execution, and reflection on action, which updates the agent's internal reflection model and action policy based on external execution outcomes. They also include retrospective reflection, to revise earlier decisions with hindsight, ensuring proper long-horizon credit assignment. Experiments on new benchmarks demonstrate significant gains over baselines, highlighting how agents can correct behavior and accumulate experience through this reflective process. Moving on, we have a critical study titled, Are You Sure? An Empirical Study of Human Perception Vulnerability in LLM-Driven Agentic Systems, by Xinfeng Li from Nanyang Technological University. As LLM agents become trusted co-pilots in high-stakes domains, a new attack surface emerges, agent-mediated deception, or AMD, where compromised agents are weaponized against human users. This paper presents the first large-scale empirical study, involving 303 participants, to measure human susceptibility to AMD. They developed HATLab, a high-fidelity research platform with 9 carefully crafted scenarios. The findings are sobering. Only 8.6% of participants perceived AMD attacks, and surprisingly, domain experts showed increased susceptibility in certain situations. The research identifies 6 cognitive failure modes and suggests that effective warnings must interrupt workflows with low verification costs. This work provides crucial empirical evidence for human-centric agent security research. Our next paper, UrbanFM, Scaling Urban Spatiotemporal Foundation Models, by Wei Chen from HCUST, addresses the challenge of creating generalizable AI for complex urban systems. While foundation models have transformed fields like genomics and meteorology, urban computing remains fragmented by scenario-specific models. UrbanFM aims to bridge this gap by systematically investigating what and how to scale for urban spatiotemporal foundation models. The authors identify 3 critical dimensions: heterogeneity, correlation, and dynamics. To address these, they construct WorldST, a billion-scale corpus of diverse urban data, introduce MiniST, a novel split mechanism for unifying representations, and propose UrbanFM itself, a minimalist self-attention architecture designed to learn dynamic spatiotemporal dependencies from massive data. Evaluated on the large-scale eval-ST benchmark, UrbanFM demonstrates remarkable zero-shot generalization across unseen cities and tasks, marking a pivotal step towards truly scalable urban intelligence. Let's turn our attention to the finite primitive basis theorem for computational imaging, formal foundations of the operator graph representation, by Qingshui Yang from NextGen Platform AI C Corporation. This paper presents a groundbreaking theoretical result for computational imaging. Traditionally, forward models for imaging systems, from MRI scanners to spectral cameras, are implemented as monolithic, modality-specific code. Yang proves that every forward model within a broad, precisely defined class of operators can be represented as an epsilon approximate type directed acyclic graph. Crucially, this graph's nodes are drawn from a minimal library of exactly 11 canonical primitives, such as propagate, modulate, and detect. The proof is constructive, providing an algorithm to generate such a graph. This theorem not only unifies the understanding of diverse imaging modalities but also establishes the mathematical foundations for the physics world models framework, promising more shareable and flexible imaging tools. Next, we examine, from performance to purpose, a socio-technical taxonomy for evaluating large language model utility, by Gavin Levinson from the University of Michigan. As LLMs are integrated into increasingly complex real-world systems, task-level success alone is insufficient to establish their practical utility. This paper addresses the gap in consistent evaluation by introducing the Language Model Utility Taxonomy, or LUX. LUX is a comprehensive framework that structures utility evaluation across 4 crucial domains: performance, interaction, operations, and governance. Within each domain, it's organized hierarchically into thematically aligned dimensions and components, all grounded in metrics that enable quantitative comparison. This framework helps align model selection with intended use, moving beyond mere performance metrics to a more holistic understanding of an LLM's true value and fit for purpose in applied, high-stakes settings. Our 9th paper, Action Engine, From Reactive to Programmatic GUI Agents via State Machine Memory, by Hongbin Zhong from Georgia Tech, presents an innovative framework for GUI agents. Existing agents typically operate reactively, performing step-by-step vision language model calls, which leads to high costs, latency, and limited accuracy due to a lack of persistent memory. Action Engine transitions from this reactive execution to programmatic planning through a novel 2-agent architecture. A crawling agent constructs an updatable state machine memory of GUIs through offline exploration. Then, an execution agent leverages this memory to synthesize complete, executable Python programs for online task execution. This design drastically improves efficiency and accuracy, achieving 95% task success on Reddit tasks with an average of just 1 LLM call, significantly reducing cost and latency compared to reactive baselines. Finally, we have PackMonitor, enabling zero-package hallucinations through decoding time monitoring, by Ziding Liu from Tsinghua University. As large language models are increasingly integrated into software development workflows, their trustworthiness is paramount. A significant issue is package hallucinations, where LLMs recommend non-existent packages, posing security risks. This paper argues that package validity is decidable through innumerable authoritative lists, making hallucinations theoretically preventable. They propose PackMonitor, the first approach to fundamentally eliminate package hallucinations by continuously monitoring the model's decoding process and intervening when necessary. PackMonitor uses a context-aware parser, a package name intervener, and a DFA caching mechanism to ensure efficiency and scalability. Extensive experiments across 5 LLMs demonstrate that PackMonitor is a training-free, plug-and-play solution that consistently reduces package hallucination rates to zero, maintaining low-latency inference and preserving original model capabilities.